doesn't reduce the bias. Cool. That's, I think, pretty basic. I think we get that. Now, for the weird part, the inference, and the applets are going to help us. You don't need to get yours out today because I'm just going to do the applets for you, but you need to kind of pay attention to how I do it. So check it out. Do students prefer name brand cookies? I almost bought some cookies, but I kind of forgot about it. 30 randomly selected high school students were asked to taste 2 unlabeled cookies and identify which cookie they preferred. One of these cookies was name brand, Chip Ahoy's, right? The other was just a store brand, just to kind of call it, basically, it's like your Kroger brand, you know, of cookies or anything like that, just plain Jane Dillon. In this case, it was called Chipmates, but it was just a generic. The order in which the 2 cookies were presented to the student was using a coin flip, so it was random. And of these 30 students, 19 preferred the name brand cookie and 11 preferred the store brand cookie. Would you agree that more than half liked the name brand, you know? More than half. There's 30 students, more than half. But what they asked, the statisticians say, is that a true representation or is it just kind of coincidence in that case? Because you only surveyed 30 people, right? So they said, let's do this. Let's use technology to see if that would be a good thing, like if students really do prefer the name brand or if that was just by chance. So just basic statistics. How do you feel about there are 2 cookies, right? And if it was an equal shot, right, that they didn't care which one, wouldn't there be a 50-50 shot, you know, since there's 2 cookies? If it was like taste didn't mean anything, there was a 50-50 shot. Well, check out this simulation that I could do. I want to show you how to do it on the applet. Again, if you need help doing this with homework, I will help you. But you select the one categorical variable, single group, and we go put our 2 guys in. So let's just call this name brand cookie, and then the other one is the store brand. And would you believe 19 students selected the name brand and 11 students selected the store brand, right? That's what happened in that experiment. So I'm going to begin some analysis. We've done this before. They made a bar chart for us. Ooh, a bar chart. But now we can scroll down and start using some of this things called inference, right? So inference is where we're going to do the survey like many times. We're going to infer what happened using technology. So I want to simulate a sample count and indicate that I want to see how many kids are going to choose the name brand. That's what we're interested in. In this one little survey, 63% of the kids chose the name brand. So the hypothesized percent is 50% because that's what like would happen if it was equal. And I want to add 100 different samples. So let's see if this works. Sometimes this 50 works. Sometimes you got to change it to 0.5. Let's see what it did. It did it for me, right? There it is. It did the sample 100 different times to where it asked for 30 people to be surveyed. What do you choose? And they did it at 50%, like would choose this and 50% that. They just kind of randomly did it, like if they flipped a coin kind of thing. So here's what we want to know. We want to know if that number 19, so if I change this to greater than or equal to 19, and if I click this count button right here, it's going to count how many students, like how many times 19 or more students did it for me. So would you believe, on my example right here, it says right here, there are 9 times where that happened in that case. And the beauty of doing it 100 times is, well, however many dots it is, that's the percent that you got, you know, because it's like 9 out of 100 in that case. That's 9%. So let's go back and answer some questions here on this guy. So I did this. Right here it says, explain how the graph illustrates the concept of sampling variability. So these will be like little drop downs on your homework. If researchers take many random sample size of size 30, because that's what I did. I did a sample size of size 30. There was 19 and 11, right? Size 30 in that case. From a population who showed no preference for cookie takes. That's why I did it 50%. The number of students in the sample will vary from about blank to blank. Here's what you got to do. You got to go on your applet and look at your low number. Our low number is 9. If you look way over here, 9, and the big number is 23, so 9 to 23. Not everybody's is going to do the same thing. You know, like if you ran this applet, your lowest might not be 9 and your highest might not be 23. It might be just a little bit different in that situation. So that's the whole concept of variability, because it was randomized. Your survey results could be different than mine. It could be different than somebody else's. In the simulation, what percent of samples resulted in 19 or more students preferring cookies? That's right here. That's this 9%. 9% did that. So 9% of the time, students, like 19 or more students, preferred the name brand cookie. So let's see what this says. In the actual study, 19 students preferred the name brand. Based on results of Part B, is there convincing evidence that students like these have a preference for the name brand cookie? First, before we fill this thing out, what's your gut feeling? Because this is where I got confused myself, and I'm the dude with the math degree. 9% of the time, 19 or more students preferred the name brand cookie. Would you say that that is likely to happen or unlikely to happen? Your gut feeling. Good for you. You know, I didn't think that was very likely to happen. I thought that was unlikely. But you are correct. It is likely to happen. Here's how I did it. Did it even happen when they did the random survey? What do you think? Did it even happen? Did it ever happen to where 19 or more students said they prefer the name brand cookie? Did it happen? You bet your butt it did. It happened 9 different times, right? It totally happened. So because the result of 19 or more successes is somewhat likely. Somewhat likely. It did happen, right? You know, it wasn't impossible. Mr. Powell's class decided that there is not convincing evidence. That to me seems backwards, but that's what the book says we got to go with, that there is not convincing evidence that students at the high school preferred the name brand cookies. Kind of weird. I think it's easier to understand if we try one more. The last example of the day, baby. It's a lot of reading, but still. Here's what they did, another experiment with candy. Researchers at the University of Michigan designed a study to find out this. The researchers gave 22 students 5 different Hershey's Kisses. You know what a Hershey's Kiss is, right? The little teardrop chocolate thing, you know? But the 5 different ones, there was milk chocolate, there was dark chocolate, there was creme, there was caramel, and there was almond. So 5 different varieties in a random order. It's like, here you go, here's one, eat it. Here's another one, eat it. Here's another one, eat it, in a random order. And students were asked to rate each one. But here's the goofy part. They were not told how many they were going to get. Right? They were just like, hey, I want you to rate these. You know, here's what you get. I'm going to give you a Hershey's Kiss. They're all going to be different. I want you to rate them by which one you like. But they weren't told how many they were going to taste. However, when the 5th and final kiss was presented, they were informed, hey, this is your last one. This is the last one. Every time when they gave them the 5th one, they said, this is your last one. They said out of all 22 of those students, 14 of them gave that final kiss the highest rating. The final one. When they were told, this is the last one, 14 out of 22, 64%, gave that final kiss the highest rating. So here's what they want to know. If you did it even, there's a 1 out of 5 shot that you choose that last one to be the one you like the most, which is 20%. That's if it was even. 20%. 64% is way freaking higher than 20%. So they wanted to know if this data provides convincing evidence that more than 20% of students like these prefer the last kiss they taste using the applet to run 100 simple random samples. So I got the applet set up for it. Here's what I set it up as. I set it up like so. Let me get this out of the way. That if you chose the last kiss, 14 out of those 22 chose the last Hershey's Kiss as their guy. That means that 8 somehow chose one of the first 4 kisses, right? There's only 2 situations. Did you choose the last one or not in that case? So I'll begin the analysis. And to run inference on it, I got to scroll on down. There we go. There's the scroll on down. Hypothesized percent is 20% because that's what it would be fair, and if I ran 100 surveys, 100 different times. I'm going to add that up, and here's what happened. Count the number of dots that are greater than or equal to 14. Count. How many times did 14 people ever say they were going to choose the last kiss? If it was fair, if it was random, how many times did that ever happen? Never. Right? That never happened. If they treated each Hershey's Kiss fairly, like it has a 20% chance of showing up, and you only ask 22 people, right, in 100 different tries, no one ever said that happened. I'm going to do it bigger. You told me earlier that if I had more than 100, it gets more accurate, so I'm going to add samples. There's 200. There's still nobody. Let me zoom out a little bit so we can see this. If I add samples again, there's still nobody, still nobody, still nobody, still nobody, still nobody. I got it up to 700 different tries. It still never, ever, ever, ever happened. So let's go back and answer these questions. Explain how your graph illustrates sampling variability. If the researchers take random samples of size 22, that's how many kids were asked originally, from a population of students who show no preference on what it tastes like. That means that's the 20%. No preference. The preferred KISS varied from about, crap, I forgot to look at it. You just go with your low and your high, so I'm going to make things up. Let's just go 4 to 10. You know, I don't remember what the boundaries were, but on that very first one, we should have looked up the boundaries. There was 4 to 10. Those were our boundaries. That's how much it varied. Based on the simulation, what % of students resulted in 14 or more students preferring the last KISS? 0%. 0% of them did that. And in the actual study, 14 students preferred the last KISS based on your example. Is there convincing evidence? What do you think? Yes or no? Is there convincing evidence to say that students prefer the last thing that they taste? It's kind of backwards of what you think, because it is, you know, unlikely to get 14 or more students to prefer the last KISS by chance. There is convincing evidence that students like these prefer the last thing they taste. So the experiment was kind of backwards. It's just like, okay, there's no way that you are just like being random with it. The last thing you tasted is what you're going to prefer. So I think thinking backwards on this last part of the question makes the most sense to me. It's like, okay, this is what I'm thinking, and it's going to be the backwards of that. So let's give it a shot on the homework.